This is Modpots by SamuPiano and GDC. So we have normal Sudoku rules, and then we have P lines here. So the sum of the digit along the line forms a two-digit number, which appears in these two cells. So one is the unit, the other the tenth, in one way or the other, and so it applies for every such line. And then the lines are also modular lines. It means every three successive cells along the line must contain one digit from each residue set of modular 3, which are 147, 258 and 369. And you can see them in the columns as mnemotechnic mean, and it continues along the line, but not for the piece. So it's each line is an independent modular line. Within the line it remains valid, but not for the piece. Means, for instance, these two might be from the same class, and lines are not related, so these two might be from the same class. And that's for the rules. So here the line span over the whole region, so the sum is 45. Well, for this line, this must be the unit, and this is the 10, so it could be 120 something, can't be 30 something. The same here, can't be 30, well, 9876 is 30, so it can't be 13, 30 something. These two. Now there's something interesting here, because we have 3 cells, so the total here is a multiple of 3. Because well, the minimum is 1, 2, 3, and you can substitute 1 by 4, adding 3, or 7, adding 6, 2, 5, plus 3, plus 6, and so on. So it's always a multiple of 3, which means this is either 15 or 24, and these are from different classes. So these two also sum to 3, 1 and 5, or 2 and 4. So now we might color this. I will color this because this belongs to different classes. 4 and 5 also. This is a multiple of 3, so this also must be from different classes, and it can't be 369, of course. Multiple of 3, 3, so this is also the opposite, the other class, 3, so this is yellow, 3 and 3, so this is purple. Now we have something here, because these are from the same class, spanning over 4 cells, and no, this is either 14 or 25, which means it would have 14. This would be the whole sum would be class 1, 147. The total, Well, if it were 14, maybe going this way, we know that these three cells sum to a multiple of 3, let's say 12. If it were 14, this would be 12 and 2, or it could be 9 and 5. But anyhow, this is the modular class of this cell and this one. So these are not 3, 6, 9, but the other one. So if it were 14, this would be 2, 5. If it were 25, this would be a multiple of 3, say 24, and this would be 1 from the class 1, 4, 5. So this is also the complement of this one. Now these three cells are the same, they are purple. These three are the same class. They can't be yellow, can't be purple either, because, well, we have 2 of this class here, can't have 4, and can't be purple either, because there's a purple in there. So these are neither 1, 4, 7, no, 3, 2, 5, 8, so 3, 6, 9. So give it blue color. This is not purple but yellow, and this is purple. For this column, still need a third yellow, which can't go there, so it goes here. This line here, there's no yellow, so this is yellow. This is interesting because this can be like this line, because if they were both purple, this would place 2 yellow here because of the modularity sum, and it can't contain a yellow, or anyhow there's already a yellow on this line there, so it means that this can't be purple, and can't be 3 because 4 cell can't sum to 30 something, so this is yellow, which means this is a multiple of 3. This is a multiple of 3, so we need 3, 6 or 9 to keep the multiple of 3. So these are 3, 6, 9. For the line, this is purple. Now this cell sees both these. So if it were 1, 4, and it's the same class, so if it were 1, 4, 14, this would be a 7. If it were 25, it would be 8. No, the minimum here is 7 and 9, which is already 15 plus something, which is at least, well, this would be at least, well, this indeed. So 3, 6, 9 and 7. 9 and 7 is already 16, so this can't be 15, but 24. And now we know the class of the purple is 147. yellow is 258. Now this line must contain a purple somewhere, and a 1 here, or a 7 here. It's 14, so if it was 7, the minimum here would be 2, 5, another 7, plus 3, it's way larger than 14, so it can't be 7 here, so this is 1. This is 3, 6, or 9. Indeed, 14. If it were 2, 5, this would be a 6 to get 14. So no, 2, 8 would be a 3, and 5, 8, and 1. No, this would be 0, so it can't. It must always contain a 2. So there's no 2 over there. This line is like this one. So this is the 12 or 21, which is a multiple of 3. So this is a multiple of 3, and we need 3, 6, or 9 here. There's no blue here, there's no purple, so there's yellow, blue here. Seven, 4, 1. 4 goes here. 7 here. These are from the same class. This is similar to this, but the complement. So it could be, let's say, 22. This is a multiple of 3, so say 18, which means to get 22, this must be from 147. This is indeed 4. 4, 8 here. This can't be 7 because it would be 27 at least, it can't work. 8, this would be 18, yes. This one is at most 21. So if it were 5 or 8, this would be 18 or 15, can't be 51. Here there is yellow in one of these two, so that's all the yellow from the row. There's no yellow in there, so the yellow for this line goes there. Now there's also a purple here. There's a purple in one of these. Purple, so this can't be purple, and this can't be yellow either, because there's a yellow in one of these. So indeed this is 3, 6, 9. Now the purple here is 4 or 7. So this, the 4 and 7 goes here. For the box. The 1 can't go on this line, so it goes here. So this is at most 21. Now if this was 7, this would be 4, placing another 7 over there. So this would be 2 times 7, 14. This would be at least 3, 6, which is 9. So 14 and 9 is already 23, which is too much for this line. So this can't be 7. 7 goes here, which means this is yellow. Purple, so this is indeed 12 for 7. And this is 1. So this is indeed 21. This could be 21, 24 or 12. So that's quite a small number, so the minimum here is 3, 6, 9 and 1, 10, 15, 19 and 2, 21. So this is indeed the minimum for this cell, which is the sum, the total. So this must be the minimum. So we have 8 and we still need 6. So 24. Here we must have a yellow, which is 8, and the 1 goes there, so this is 1, 8. this is not yellow but blue, and for the line and the box, these are yellow. So this is 3. Now we have 10, 14, and this is 22, so still need 8. Here we have 9 and 6, 15. So it can be 12, so it's 21, and we still need a 6. We have 19, this is 24, so we need a 5. Seven goes here. 5, 3. This must be, can't be 40 something. So this is the unit, this is the 10, so 24. And here we have 2, 3. 2, 3, and we need a purple here, so 4, 7, and 9, so 9, 4 and 2, well this is 15, okay, and this is 8. We have 4 and the 6 and 9. 1, 2 and 3. 2 goes here. So for this line, this is yellow, which is 8. This is 6, 9. So purple here. This way for the line. 1, 3. 7, 6, 3, 6, 9, so this is 7, 9. 6, 9, 6, 4 and 9. Here we have a 1, 8, 3, and then a 5 or 8. 1, 3 is 4, this can't be 21, so this is 12. 1, 3, and 4, and we need an 8. So 8. 3. check for this line. I suppose this is correct. So 1, 2, 3, 4 is 10 and 14. Well, this is 24. So good so far. Maybe this is my familiarity with the modular lines. It's rated 4 star out of 5, which is quite hard for LMD, but I didn't find it that much difficult. Usually I can't solve a puzzle of 4 star, not speaking of 5 out of 5. I don't even try these. But well, for me it was not that hard.